the definite combination to get your morning started off right. Matt Sellen, physics professor at the University of Illinois, is here to talk about, what are we talking about today?
Well, a few minutes ago, in that first shot, we had that light stick where we had a bunch of loops of wire that were threaded down along this clear lucite rod, and we dropped a cow magnet down it, and the lights flashed.
Right.
Okay, and so what happened there was that as a magnet falls through a loop of wire, it induces a current to flow around that loop of wire. Now, if a current is flowing in a wire, we know what happens is that you get a magnetic field. And maybe you didn't know that's what happens, but if you just take a wire and you wrap a wire around a nail and you just attach that to a battery, you can pick up paper clips. And a lot of kids will try that at school. And I should have brought that in here, but I forgot to do that. So anyways, that loop of wire causes a current. You can saw the lights flash, but it also makes a magnetic field. And the interesting thing is that the direction of the magnetic field that's caused by the current that flows in the wire is in the opposite direction of the magnet that's falling through it.
Oh, okay.
So it tends to slow the magnet down because it's the, the opposite ends or the same ends of a magnet repel each other. That's how you can think about it. And so you didn't see the thing slow down very much as it fell through that clear plastic rod because there was just a little bit of metal there. But we dropped the magnet through this
copper pipe.
The copper pipe, and it took a very long time to get to the bottom. Now, I have here a really strong magnet, this neodymium magnet, which is just a little tiny disc.
You don't get those at your basic drugstore, do you?
You might. I think you can probably get them at a hobby store or something like that. I don't know. I ordered these online. But I'm just going to put this in here and let it go. So there it goes. And now you can hear it, but you can't see it yet.
Can't see it, no.
It's moving down this pipe very, very slowly.
Okay.
Because this magnet is so strong, it's inducing rather large currents. And so the motion of this magnet is just slowed down. There it goes. That's where it finally ended up.
That
So
this
thing fell very, very, very slowly down through this pipe. Now, the bad thing is you can't see it. It's just kind of surprising that it takes a long time. So what I have, that's loud. What I have here is a very strong magnet that I got by taking apart a disk drive from an old computer. Don't try that at home because somebody might be mad at you. And now the new disk drives don't have these very strong magnets anymore, but they used to have very strong magnets. And let's make a little ramp out of a piece of wood. I'm just going to slide this magnet down it. It slides pretty quickly.
No problem.
Let's make a ramp out of a piece of copper. Let's slide the magnet down it.
Very
how slowly that moves?
Yeah.
Now, you might be thinking, well, it's just a magnet. It's sticking to the metal. But it doesn't. Copper is not a magnetic material, so it doesn't stick to this at all. What's really happening is as this thing moves, it's inducing currents in the copper. Those currents make a magnetic field that opposes this thing's motion, so it takes a very long time for this thing to slide down. Now, those currents will be bigger in a material that is, I better get my glove. Sorry, I threw it over here.
Don't try this at home without your gloves. There you go.
Here I have a piece of copper that's been in liquid nitrogen. It has lower resistivity, less resistance because it's very cold. We talked about that a few weeks ago.
It is very cold.
So when I
do not handle it without a glove.
When I do it with this one, you'll see it slides down very, very, very slowly.
Right.
And if you could zoom in on this, you'll see something very interesting. If I just let this thing fall, see what it does. See how it kind of very gently falls?
Right.
And it sort of hovers a little bit, and then it flaps down?
And that's because this is so cold.
It's so, yeah. So I think that's pretty interesting.
That is pretty interesting.
And it's all because magnetic fields that move induce currents, and those currents produce other magnetic fields that oppose the ones that were there to begin with.
Like I said, magnets, the liquid nitrogen, and the wise guy. You can't beat it. Now, do we have a question for next week? Well, let's see if the viewers have any questions for next week. Go to our website, wcia.com. There's a link to the Wise Guy's website, or you can contact him directly. Wise Guy at UIUC.
We're going to talk about generators and things like that.
We'll talk about generators. Okay, thank you so much, Matt Sellen.